So Dimitri, good day. It's nice to have you here today. We're going to have a short interview on your experiment, AUXPRINT. I would like to welcome you on that. I know you have some experience with AMable, but let's look into a detail on your new feasibility study, which was on 3D printing of oxidative structures. But before we start, can you explain to us what exactly SIMLIT does, where you're situated, and what you exactly do in your company?
Yes, hi Lucas. So SIMLIT is a product design and innovation agency based in Cyprus. We use our creative skills, design knowledge, and engineering expertise to deliver innovative products and bring game-changing experiences to life. Overall, we offer services in product strategy, research, product design, engineering, and prototyping.
Nice. And what was exactly your product idea within the AUXPRINT AMable project? Can you describe this in a little bit more detail?
Yes, of course. So the ultimate goal of this project was to study, develop, and optimize enhanced additive manufacture cores in order to replace conventional components such as honeycombs in sandwich structures for impact applications, including aircraft, sports, automotive, and consumer goods. So in general, oxidic materials are materials that undergo lateral expansion when stretched longitudinally. Therefore, our aim was to develop pioneered oxidic structures where based on simulation-driven design approach, we have altered the oxidicity response in all three directions.
Yeah, thank you for the detailed explanation. And what were exactly your expectations for additive manufacturing? What makes the oxidic structure so special that additive manufacturing was able to support you further with your product idea?
Additive manufacturing provides an opportunity to explore different geometric aspects of oxidic core structures with a variety of different core materials.
At the beginning, you had probably expected to have some challenges. What were these challenges, and how did they change on the way of performing your experiment?
In the beginning of the project, the main challenge was to implement successful numerical studies in order to optimize the oxidicity effect of hard and elastomer polymer materials, with an additional challenge based on the design for additive manufacturing in order to enhance the mechanical properties of the sample based on each 3D printing technology.
Okay, in order to support you with these tasks, which AMable services did you choose for your experiment, and
So,
why did you do that?
we choose two of our services, the materials for additive manufacturing from Inspire and DTI, and the modeling and simulation from Frederick Research Center. So materials for additive manufacturing were chosen to examine the parameters of FDM and SLS technologies regarding geometry specific requirements, as well as to guide us for appropriate material selection. On the other hand, modeling and simulation was chosen to understand the underlying physics that control the macroscopic behavior of additive manufacturing components.
And how has been your experience with this support from the services until now?
Our team has gained valuable knowledge and support from the tutor and controller of our experiments during this project. So this is an opportunity to thank you, Lucas, for your continued support, feedback, and encouragement. Now, from the AMable support, all providers have shown extreme support in providing all needed information, guidelines for the appropriate fabrication of the 3D printed oxide structure, as well as simulation studies to support our design iterations.
Now, Dimitri, I'm the one to thank you for the very smooth collaboration and really interesting project idea. And what are your plans when will be your product or this product idea available on the market, or how can it be, or when will it be implemented on specific products?
First, the target market of our product are EU manufacturers of personal and sports protective equipment with the aim to receive collaboration agreements. So the primary objective of our market strategy is to launch AUXPRINT products into Europe during 2023. And based on our initial forecast analysis, we estimate to gain the 0.25% of EU market by the end of 2025.
Excellent. Yeah. And since I know from our recent discussions, you have other plans of other additive manufacturing products which were coming up or were related to AUXPRINT experiment, wasn't it?
Yes, yes. Through the AMable program, we have successfully completed two additive manufacturing experiments, the AUXPRINT, as well as the Optima experiment from OpenCall 2, where by means of SLM technology, selective laser melting, we have developed conformal cooling channels in injection molds to reduce the cycle time and enhance the physical and mechanical properties of the end product. And as you mentioned, Lucas, we are planning to use these oxide structures developed in this project as a metamaterial lattice for orthopedic implants in order to enhance the mechanical compatibility requirements for such applications.
Yeah, that's excellent. I wish you all the best, Dimitri, on that. And before we close our interview, can you please give us your overall impression experience with working with AMable project?
Yes, of course. So AMable has helped us to gain technical knowledge for the proper design of additive manufacturing products, post-processing and testing techniques that are required in order to reach the optimum performance of plastic and metal components. So we are confident that due to our investment in additive manufacturing technology, we will gain an advantage over competition of being cost effective, agile, flexible, and innovative.
Thank you very much, Dimitri. We wish you all the best, and we will definitely be in touch in near future for further work together. And we are glad that you enjoyed the work with AMable. Thank you.
Thank you, Lucas. Thank you for this opportunity.